All right, for Algebra 9.8 notes, we are going to learn really quickly the system of linear and quadratic equations. So we've done systems of equations before, but if you remember, it was where one line that was linear intersected another linear line, and we found where they intersected. Their point was their solution. So this is the same thing, except now we have one that's linear and one that's quadratic. So when would you encounter a situation like this? Here's an example. Two scooters, so looking at this little picture on the right here, two scooters leave a stoplight at the same time. The blue scooter, which you can't really tell which is which, but it's this first one. So this blue scooter accelerates. Oh, sorry. No. This would be the blue one. So the blue scooter accelerates and then travels at a constant speed. So it changes speeds. It accelerates and then travels at a constant speed. So that would make it a quadratic function because it changes speeds. However, the red scooter, which would be this one, accelerates at just a constant rate. So it takes off and continues traveling just at that speed the whole time, which would make it linear. So if you graphed both of these, you would find where they intersect, and that would show when the red scooter catches up to the blue scooter. So that point of intersection is where they would meet. All right, here's the essential understanding. When you're looking at it graphically, you can just look and see where they intersect. So if you're looking at a graph, a linear graph and a quadratic graph may have two solutions. That may mean it intersects twice. It could have one solution. That would be where the linear graph and the quadratic graph meet at just one spot. Or they could end up having no solutions. So it could be a linear graph and a parabola, a quadratic graph that never intersect. In that case, there would be no solutions. So for our essential understanding today, you can solve them graphically. We can also actually solve them algebraically, but for Algebra 1, we will not be solving it algebraically. We will only be looking at them graphically. So later, you will be doing them algebraically as well, like with substitution and elimination and things like that to find their intersecting points. But for our purposes, we will only be looking at them graphically today. So two solutions look like this, one solution, or there could be no solutions. Here is their example. They have gone ahead and graphed the parabola that matches with x squared minus x minus 2. It looks like this. And then they have graphed a linear, y equals negative x plus 2, which looks like this. So this answer is they meet in two solutions. One would be negative 2 comma 4. And the other solution it meets right here is at 2, 0. So this one has two solutions, and they are negative 2, 4 and 2, 0. Okay, I'm going to show you a couple different ways to do this. The first one is just graphing. So I'm going to take this quadratic equation, y equals 2x squared plus 1, and we're going to do what we do when we solve graphically, and that is make a table. I'm going to plug in 0 because 0 is very easy to calculate. 0 times 0 is 0, times 2 is 0, plus 1 is 1. So one dot would be at 0, 1. Okay, I'm going to plug in a 1 because 1s are really easy to plug in as well. 1 squared is 1. 1 times 2 is 2, plus 1 is 3. So we'll put our next dot at 1, 3. 1, 1, 2, 3. All right, and then let's try a 2. So 2 squared is 4. 4 times 2 is 8, plus 1 is 9. So our next dot is at 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember from our parabolas earlier, you know that if this is shifted up 1, but it's twice as stretched, it is going to look like the parent function. It's going to be right here. So these points are going to be able to be reflected over. If you're not sure, you can plug in a negative 1. I guarantee you will get 3. And you can do a negative 2, and you're going to get 9 because these points are just reflected over. Okay, so you're going to draw in your parabola. I'm going to hope that you remember how to graph a linear function just from slope and y-intercept. If not, you could absolutely make a little table of x and y values over here for this one as well. but I'm just going to know that my y-intercept is 5. So I'm going to go to 1, 2, 3, 4, 5 and put my dot. And then I know that's a negative 2 over 1 slope. So I'm going to go down 2 over 1. And I see they intersect right there. Down 2 over 1, down 2 over 1. Okay, I'm going to go back up 2 over 1, up 2 over 1 again. They intersect right there. So I'm going to draw in my linear graph. And I can tell that these have 2 solutions. They intersect twice. So 2 solutions. And the 2 solutions are negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 2, 9. And 1, 1, 2, 3, 1, 3. Okay, I'm going to show you really quickly on my Desmos calculator. I'm just going to type in both of these. I hope you know that on Desmos, you can type in multiple equations and it'll graph everything all at once for you. So our first one was y equals 2x squared. There we go. Let's get rid of that now. Plus 1. And then I'm going to go down to another row. So there's my parabola. I'm going to go down to my next row and I'm going to do the linear one, which is y equals negative 2x plus 5. Okay, so that's what we graphed. I can even come over here and zoom in and see it a little closer. I can pull it down. So I can see that these are going to intersect at negative 2, 9, and at 1, 3. So these actually will graph it for you. Okay, so let's go back to our last one. And just in case you need more practice graphing, I will write in this one over here. So if I choose a 0, 0 squared is 0 plus 3 would just be 3. If I choose a 1, 1 squared is 1. 1 plus 1 is 2, plus 3 is 5. So I'm going to put a dot at 1, 1, 2, 3, 4, 5. And let's say I pick a 2. 2 squared is 4. 4 plus 2 is 6. Plus 3 is 9. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And because we know that this parabola is just going to reflect over, we can put a dot there and here as well. Okay, I know that you guys know how to graph a linear function. The y-intercept is nothing afterwards, so we know that the y-intercept is 0. So we'd put a dot at 0, the origin. And that is a hidden invisible negative 1 slope, so down 1 over 1. So we're just going to go down 1 over 1, down 1 over 1, back up the other direction. And I can tell already that these two graphs are never going to intersect. So you can draw them in, and you can see that they will not meet. So this is an example of a no solution system of linear and quadratic. I also want to go back to Desmos really quickly and just type in these two equations just so we could have done it that way to begin with. It's just that since your notes gave you a graph, we might as well practice graphing it. But the first one was y equals x squared. I'm going to get rid of that again. Plus x plus 3. Okay, so we saw it shift up 3. And then my second equation was y equals negative x. So there they are, and they are never intersecting. So there is no solution. All right.